So, hello everyone. A very good evening to all of you. I hope I'm audible and visible. Can anyone confirm me? Yeah, I'm audible or visible. So, yeah, let's wait for 5 to 10 minutes so that everyone can able to join this session. Okay, thank you for confirming. Okay, so let's start the session. So hello everyone, my name is Pooja Verma, MPMRF Research Scholar from IIT Kharagpur, and instructor for this course is Professor Shantanu Chattopadhyay from Electrical and Electronics Engineering Department, IIT Kharagpur. This is a week 2 live interactive session on digital circuits. So for asking and interacting, you can use chat box as well as you can unmute yourself and ask your doubts and questions. And also I will suggest you please carry one calculator for solving problems. So I hope all of you have gone through this week video lectures. So these are the content topics which have been covered for this week. So first we will go through some theoretical concepts, then we will solve some numerical questions or problems. Okay. So for this week, this is the outline for this week. Floating point numbers, floating point representations, floating point standards. For example, single precision or double precision, IEEE standard, roundings and error, then Boolean algebra. In Boolean algebra, then logic gates and or not gate, then basic theorems of Boolean algebra and representation of a Boolean expressions, sum of product form and product of sum form, then canonical form or for expression, standard form. Okay. Okay, so first one is a floating point numbers. What is a floating point number? Why we required for floating point representation? So two's complement representation, as we have seen that one's complement, two's complement, and sign representation. So that deal with the sign integer values only, but without modification, these formats are not useful in scientific or business applications. That's why we deal with the real number, where we deal with the real number values. So floating point representation solve these type of problems. So floating point numbers allow an arbitrary number of decimal places to the right of the decimal points. For example, 0.25 multiplied by 0.25 is equal to 0.125. It is, we can represent it in pen or paper, but how we can represent in a computer? So in computers, mostly we represent in the scientific notation. For example, we can express this 0.125 like 1.25 into 10 to the power minus 1. Or we can express the 5 lakhs or something, 5 into 10 to the power 6. These are the scientific notations which we can represent in the computers. Now next, computer use these scientific notations for floating point representation. Numbers written in a scientific notations have three components. First one is a sign, then mantissa, and then exponent. Sign means plus or minus sign, and mantissa is that decimal place integer values, and exponent 10 to the power something or 2 to the power something. These are the exponents. To represent in the computer, these are the things which we can represent in the computers. But here we can, in a way, we can write it with this way: sign, exponent, and significant. In a computer, we can able to represent in this form. These are the, this is the example which what the numbers, what we can say that, and for representation in the computers we can represent in this format. Okay, so I hope all of you have gone through this and you have seen the some examples in the video lecture. So I am not going much deeper. We will solve the some problems that we are able to understand. Okay, so there there are some models which are useful to represent this floating point representation. First one is a simple model in which a floating point number is a 14 bit length. Let's consider that. And in that case, the exponent field is for 5 bits and significant field is allotted to the 8 bits. Okay, but the limitation with this simple model, I hope all of you have seen that the examples on that. Otherwise, we will solve some problems based on that. You can see there. But the limitation of the simple model is not only do these synonyms representation that waste space or memory and also create lot of confusion for using this simple model. And another limitation for this problem, this system is it does not allow the negative components. If we have to represent 0.5 or 2 to the power minus 1, then there is a no system to represent this. So to resolve this problem of synonyms form, to we establish a rule that first digit of significant must be 1 with no one to the left of the radix point. So this process is called normalization, and this unique pattern for each, there is a unique pattern for each floating point represented. For example, 4.5, this is a binary representation of 4.5, and if we want to represent in a computer, so we have to write like this: 1.001 into 2 to the power 2. But for a normalization, what we have assumed that the first digit of significant must be 1. These are the significant, these are the exponents. So first digit of significant must be 1. So for that we normalize this. So this one is the correct representation of that 4.5. And to provide the for negative exponent, we will also use a biased exponent. But problem is that here we cannot use the negative component or negative exponent. Here is it is a positive 2 to the power 3, but if we have 2 to the power minus 1, then we are not able to represent in this. So for this we will use the biased component. So in the biased component you have seen one example for 16 bits. So we are adding or removing the 16 number 16 for this. So a bias is a number that is approximately a midway in a range of values expressible by a exponent. We subtract the bias from the value in the exponent to determine its true value. We will add or subtract the exponent from the bias value. So we will see after that what is bias, how we will use for the other method. Now, what are the floating point standards? So there are two floating point standards which is established by IEEE. One is single precision and another one is double precision. That is called IEEE 754 single precision floating point standard, that uses 8 bit of exponent and with a bias 127. This is a bias for single floating point, and for significance it is 23 bit allotted. And another one is a double IEEE 754 double precision standard, which uses the 11 bit exponent with a bias 1023 and 52 bit significant. Okay, so these are the two standards which have been used for floating point. So in both the standards, single precision and double precision, floating point standards, the significant has implied 1 to the left of the radix. Okay, so this is the rule. This is a IEEE format to represent a single precision or double precision. Okay, so 1 must be there whatever we are representing. For example, here 4.5 can be represented like 0.1001. When you will change it to the binary, then you can able to, then for IEEE format representation 1 should be a left side of the radix point. So this is the correct one. So we have to normalize this. Okay, that means does not need to listed in the significant. So the significant would include only that part 0 0 1. Okay. Okay. So next one is a Boolean algebra. So Boolean algebra first developed by English mathematician George Boole in between 1815 and or 8 to 1864. It described as an algebra of logic or algebra of two values, either true, false, or true or yes. True means yes, or false or no. The logical operations have been performed by a logical operators. The fundamental logical operators are and, that is called also conjunction, or it is also called disjunction or not, negation or complement. We will go into deep and or not gate. There are also gates are also there. So what is a truth table? Truth table is a table that contains all possible values of a logical variables in a Boolean expression. For example, if we have here 2 to the power n number of combination, when n is the number of variable. For example, 2 to the power 2 means 4, 4 combination. N is 2 means 2 variables. For example, x or y. So how many combination will be there? 4. So for that, how we can make? So that all values can be 0 0 0 1 1 0 or 1 1. So that can be contains all possible values of x or y. And next one is what is it? Tautology or fallacy. If the output of Boolean expression, that means the output of this, it's all one or true, it is called tautology. And if the expression of output of this Boolean expression is zero or zero, then it is called fallacy. Next one is a logic gate. So a gate is a digital circuit which operates on one or more signals and produces single output. So gate of the digital circuit, because input and output signals are denoted by either 1 or 0. 1 means high voltage and 0 means low voltage. There are three types of gate are AND gate, OR gate and NOT gate. So I have not taken here the AND gate, OR gate and NOT gate in detail. So I am just covering the what are the things have been covered in what is. So AND gate is represented by, for example, Y. There are two inputs A and V, and it is represented by this symbol. Here A and V, two inputs, and Y is the output. Similarly, OR gate is represented by this symbol, where A and B are the inputs and Y is the output. And the output Boolean expression for OR gate is A plus B. And similarly, the NOT gate is represented by this. It is only one input, just it complement the input A bar. So these are the AND gate, OR gate and NOT gate. Their truth tables are also available in lecture video. You can see from there. So what is the principle of duality? While we are going to solve the problem, these are the important concepts which are required while solving the problem. So principle of duality is an important concept. So in principle of duality is in Boolean algebra, the duality principle is obtained by interchanging AND gate and OR operators and replacing zeros by ones and ones by zeros, and compare the identities on the left side with the identities on the right side. For example, A plus B is there. So if it is follows the principle of duality, So what we have to do, we have to change AND operator to OR and OR operator to AND. So here it is a OR operator. So what we have to do, A dot B. Okay, and if it is there any expression there is zeros, so it will be replaced by 1, and if 1 is there it is replaced by 0. It is a principle of duality. Next on the basic theorems which have been widely used in the Boolean algebra, there are 10 basic theorems. It is very much important for solving the questions. I hope you have learned or gone through this theorems. So theorem 1 is properties of 0. If you add 0 in any variable, it will be a only, and similarly if you multiply it with 0, it will be 0. And another one is properties of 0. If you add anything in 1, then it will be 1 only, and if you multiply with 1, it will a. And commutative law, a plus b must be equal to b plus a, and similarly for multiplication, a b is equal to ba. And associative law is that if you add a plus b first, then add c, it must be equal to a plus in brackets b plus c. Similarly for multiplication, it is also true. And this is a distributive law. A in brackets b plus c is equal to ab plus ac. You just need to multiply, it must be equal. And similarly, a plus bc is equal to a plus b and a plus c. If you solve this, you will get this one only. You can write a dot a. If you multiply this, a dot c plus ba plus bc. So a dot a is a only, and a plus c, a plus b plus bc. If you take a, so 1 plus c will left, and 1 plus c, that means 1 here, so it will be, and again you will take a, so 1 plus b will be left plus bc. So a plus bc you will get. You can solve like this. Similarly, a plus a bar b is equal to a plus b. These are the some important concepts and theorems. And identity laws are also the a plus a b b. A only, a is a, and absorption law says a plus ab will be a only. For example, if you take a, 1 plus b will left, so a only left. And similarly for in the multiplication also, a plus b will be a only. Complementary law is the x plus x bar will be 1 and x bar will be 0. Involution means x double bar is equal to x only. And this T10, that theorem 10 is also very important, De Morgan's theorem, that said that x plus y bar is equal to x bar into y bar. That follows the principle of duality also. X into y bar, this is 1 2, it will be x bar plus y bar. So these are the important theorems which is very useful while solving the problems. Please learn these. So now next is representation of Boolean expression. So there are two types of representation of a Boolean expression. One is sum of product form, that is also called SOP, and another one is a product of sum. Product of sum, and example of sum of product AB plus AC, and for product of sum is A plus B and A plus C. Product of sum means sum plus first sum, then products by taking products on that, and sum of products, the first product, then sum it. Okay, and next one is what is a min term and max term. So individual term of canonical sum of product is called min term. Individual terms, that means of this individual terms are called min terms. And min terms is a product of all literals. means that all the variables. It is a product of all literals within a Boolean expression. Similarly, the individual term of a product of some part is called max term. That individual part is called max term, and it is also sum of all literals. It is represented by sum of all literals, and for SOP it is a product of all literals. Just remember this. Sum of SOP in POS. Okay, so now next we will move to the questions or problem set. So first question is, which of the following is a IEEE single precision floating point representation of 6.625 in decimal? It is in decimal. Then what is a floating point representation of IEEE format in a single precision? Okay, so how you will solve this? So it is given in a decimal. So first we need to convert it into a binary, right? So what is a binary of this? Can anyone tell me in the chat box? Please respond. Oh, okay. Yes, sure. Now you are able to see the decimal number is 6.625. What is a binary representation of this whole number? Not only 6. Okay, so binary you can solve it. So binary representation of this is 110 for 6. Okay, it is a 116, and for 0.625 what is a binary representation? Just you have to multiply with 2, right? Then you will get 101. It is a binary representation of 6.625. So as we know that IEEE single precision floating point standard uses 8-bit exponent, right? There are 3 columns are there. So I'm making it short. Yeah, correct. So first is sign bit, next one is exponent, right? And it is a significant. As we know that sign bit is represented by 1 bit, and it is exponent is given to 8 bit in a single IEEE single precision floating, and the significant bit is given to 23 bit, right? So in the IEEE with bias 127, just remember this one also, bias is 127. So now we have to represent it in a IEEE single precision floating point. So what we need to do, we have to just make the decimal to this 101 into 2 to the power 4, right? No, 2 to the power 3 it is. So it is given in the IEEE single precision, left bit must be 1. Okay. So it is a IEEE single precision floating point representation. Now what we need to do, we have to normalize it. So if you normalize it, that is 1.10101 into 2 to the power 2. Yeah. And also we need to add a bias in the exponent part. The bias is 127 add that is in a positive, so we need to add. If it is a negative, then we have to subtract. So it will be the 129, right? Now you have to find the 129. It is in decimal, so we have to convert it into a binary, right? So again, we have to convert it in a binary. So can anyone tell me what is a binary conversion of 129? So okay, I'm converting it here. So just what we need to do, we have to divide by 2, right? 1 left, 0. Again, if you divide it, 0 and 1. 0. So what we got? 1, 6 times 0, 1. It is a binary conversion of 129. It is an exponent. So we have to write it into an exponent area. And also we know that it is a positive number. So sign bit is 0 and binary conversion of 129 is this 1. 6 times 0, that is 6 times 0, 1. And after that the fraction part, that is 1, 0, this part 1 0 1 0 1 till 32 bit, because the length of the significant is 23 bit, sorry, not 32, 23 bit. Okay, so option A is the correct. So have you understand this question, how you will solve this? I hope all of you have got this question. Okay, okay, so moving to the next question. So next question is also related to this only. Represent the single precision floating point binary number C 0 7 5 times 0 in, it is in hexadecimal, now in a decimal. Okay, so now how you will solve this? So first what we need to do, first we need to represent it into a binary, then after that we have to convert into a decimal, and by using the single precision floating point binary representation. Okay, so how we can move forward? Okay, so what is a number allocated for C? 12, right? So what is, it is a binary representation of 12? 1 0 1 0, right? No, no, it is a 1 1 0 0. Yeah, it is a 1 1 0 0. So now, and for 0, 4 times 0, right? Because it is in hexadecimal, now we have to convert it into a binary. So for every bit there is a 4 bit allocated. And for 7, similarly 0 triple 1. And again there are 5 zeros, so for every zeros there are 4 zeros in a binary representation. Okay. So I'm writing it here correctly so that we can So for C, it is 1100. Again for 0, 4 times 0. And for 7, 0, 111. Yeah. And again for 50. Okay. So now, if you see that the total number of bits, then here 1 is for sign and next another 8 bit. It is 8 bit allocated for what? Exponent. So just take 8 bit. 8 bit for exponent and 1 bit for sign. Now 23 bit left. If you count it, just count it and see whether it is 23 bit or not. So what is represent? It is a single precision floating point representation. Okay, so this whole bunch represent the single precision floating point number. So first is digit is 1, that means it is a negative number, right? So now we have to see the 8 bit exponent. So what is it? Decimal number of this 8 bit? If you see that it is a 128 if you convert it. Okay. Yeah, B is correct. That is written, but solve it. So it is 128. So as we know that the bias is added in the exponent part, so just remove the bias. So 128, the bias is for single precision floating point is 127. So if you subtract the 127, you will get 1. So that means exponent is 2 to the power 1 for this. Okay. Now this is a significant part. Okay. This is a significant part. So now what are the significant part? That is 1, 1, 1, 0, then 0, 0, 0, all 0. And if you represent all in the so 1.111 into 2 to the power 1, right? In a wholesome way. So this is the exponent part, this is the sign part, and this is a significant. Here we have added till 23 zeros, so everywhere we don't require to write it. So now convert it 1, what we get 1.11, but it is in binary only. Now convert it into a decimal. If you convert it into a decimal, and also already we know that the sign bit is 1, so it is a negative number. So just convert it 11.11 to decimal. So you will get here 1 into 2 to the power 0 plus 1 into 2 to the power 1. So 2 to the power 2 plus 1 is 3 in the integer part, and into a decimal part what we will get 2 to the power minus 1 into 1, 2 to the power minus 2 into 1. So we will get 1 by 2 divided by 1 by 4, that is 3 by 4. If you convert 0.75 we will get. So here the integer part is 3.75 and the first digit is 1, so it will be the minus 3.75. Okay, so the correct option is B. B is the correct option for this. So I hope all of you have understand this or got this. If you have any confusion, you can ask. Otherwise, we can move to the next question. Yeah, ma'am, how do we change the hexadecimal to binary form? So already you have seen that For every hexadecimal, to binary conversion, for every hexadecimal number, there are 4 binary bit are required. Already you have seen in the previous class, C is represented by 12, and how you can represent the 12 in a binary. So by dividing 2 2. Otherwise, there is a 8421 rule. From there you can directly get the binary number. Okay, so for C, the 12 representation of a binary is 1100, and for 0, so I have told you for every bit in a binary there is a 4-bit representation. So 0 for 0 is also 0, 4 times 0. For 7, similarly you have to change it in a binary. So 0 1 1. If you take the 8421 rule, so just you add 4 2 6 1 is 7. Okay, and for every 0, 4 times 0. So that's how we are converting hexadecimal to binary directly. So yeah, have you got this? Yeah, have you got the one, Sagar? Okay. Okay, so moving to the next question. So next question is, okay, okay, yeah, can. Okay, so to convert the hexadecimal, here the question is represent the single precision floating point binary number C into a decimal. So we can directly convert, but that is here it is said that by using the single precision floating point binary number. So what we need to do here, convert this hexadecimal into a binary. So already you have studied in the previous week 1 lectures to how to convert this hexadecimal directly into a binary. So already we know that for hexadecimal 0 to 9 we represent by a number. After 9, for example 10, 11, A, B, C, D, E till E, F, that we can able to represent. So what is the representation for C is 12. So find out the binary representation of 12, that is 1100. Binary representation of 12 is 1100. You can find it out in a 2 ways. First, by dividing or by converting into a binary, it is a decimal, you can convert it into a binary, or by using 8421 rule. 8421. So for every bit the weight is allocated. So if you just you need to add, that means 8 plus 4 12, wherever it is in 1, add this weight. So 8 plus 4 is 12. So C is represented by 12. So this is a binary representation of C. Now it is in hexadecimal. So for every bit there are 4 bit representation is there. So for C it is a 4 zeros will be there. And again for 7 there is also 4-bit allocated for 7. So what is the representation for 7? Just add these ways, 4 to 6 plus 1, 7. So you can 0 1 1 1. It is a binary representation of 7. So you can write after that 0 1 1 1, and for every bit write 4 4 zeros. Then you can find it is in a single precision floating point format. Just allocate for sign bit, exponent part and significant part. So as we know that for sign bit there is a 1 bit allocated, and for exponent it 8 bit allocated, and for significant 23 bit allocated. Just find it out. Okay, so as we know that first bit is represented whether number is positive or negative. So it is 1, so that means number is negative. Okay, that part is completed. Now come to the exponent part. just it is given in a binary. So just find it out decimal number. What is the decimal representation of this binary? So if you find it out, you will get 128. So in the single precision floating point number, as we know that bias we are adding in the exponent part while we are solving the problem. So just remove that bias part, you will get the exponent. So for single precision floating point, the bias is 127. So 128 minus 127, you will get 1. And exponent, you will get 2 to the power 1. Right? Now, the significant part is there. So you don't need to calculate for all 23 bits. Just take the initial 3 or 4 bit. It depends. Okay, so initial 3 bits had been taken. So the first bit is 1 point, the 3 bit 111 into 2 to the power 1 multiplied by exponent. And now if you multiply, you will get 11.11. Now it is in binary, convert it into a decimal, you will get minus 3.75. I hope you understand this. Sign bit is also taken for significant parts. No. So here in the if you go through the rules of the single precision, so already told in the this lecture you have seen what is it format of IEEE single precision format. So it is in this format. 1 point, the 1 is always left in this part. So you have to just follow this rule. Okay, for solving the questions. So 1 always in the left of the decimal. Okay, so I hope now you have understand this. So moving to the next question. So next question, simplify the given Boolean expression A, B, C plus A bar B plus AB C bar to minimum number of literals. Okay. So how you will simplify? A, B, C plus A bar B plus A, B, C bar. I am representing this bar to this side. You can represent in either in this way or either in this way. Okay, now we need to minimize. So just see the Boolean expression and try to minimize it. So minimum number of literals. The individual this it is called literals, either A, B or C. It is called individual literals. Okay. So now first we will try. So if you take AB here, be common or if you take the AB in both common, so what you will get C plus C bar, right? We need to check from where we can make a common point. So it will be the A bar B. Now what left? AB. As we have seen that in the theorem, C plus C bar or A plus A bar will be 1. Right? So what left? A B plus A bar B. Now we need to take common B because B is common here. What left then? A plus A bar. So A plus A bar is equal to 1. So only B is left. So correct option is A. A is the correct option. Yeah, okay. It is clear. Okay. Okay. So moving to the next question, if it is clear. So again, The same simplify the given Boolean expression a bar bc plus abc bar plus abc plus a bar b c bar to minimum number of literals. Now you can solve this question without seeing answer. Please solve this question and let me know which option is correct. A bar bc plus abc bar plus abc plus a bar b c. Please answer in the chat box which option will be correct for this to minimize the number. Please try to solve it, at least give the answer. Option, okay. Whether are you saying option B or B is the answer? We were typing only B. Option B or B is the answer? Okay, okay, yeah. Okay, so let's solve this. Now we have to make a common. So A bar B. So here A bar B will be the common. So what left? C plus C bar. I am taking this one and this one first. Then what is next? What will be the in the next common? Here ABC and AB C bar. So no. Okay. So first A, just I'm taking it clearly. Okay. So first take BC and from this one and this one, so what left? A plus A bar. They take this one. Now next, what we need to do? B C bar. Second one and fourth one. Then what will be left? A plus A bar here also. Now A plus A bar, as we already know, that equal to 1 by the Boolean theorems. What left? B C plus BC bar. Now take B common. So C plus C bar. Again it will be 1. So only B will left. Okay. So correct option is option C is the correct option. Answer is B. Okay. I hope all of you understand this. So moving to the next question. Okay. So the next question is 1.5. It is in decimal. 1.5 plus 3.25 equal to x. It will be also in decimal. Now, the value of x in IEEE 754 single precision floating point representation is. Now, the floating point representation we need to represent in a hexadecimal. So, what will be the addition? Will be the equal to x, and now after that we need to convert it into a decimal. So, how we can solve this question? How can proceed further? Just a okay, sorry for the disturbance actually. Okay, So can anyone give the answer, or we can solve it? You can solve it by two ways. First, either you can convert it first into a binary, then both, then add it and then convert it, or the both base is same, so you can directly add it also. Okay. So now we are going to, so if you add 1.5 and 3.25, both are in decimal, so we can add it. So 4.75 is in decimal, right? Now we need to convert it into a binary. Okay. In order to find out IEEE 754 single precision floating point representation. So how you will, what is a binary representation of 4? That is 1, 0, 0, right? And for 0.75, you just need to multiply 0.75 by 2, then you will get. So what you will get? 1, 1. So it is a binary representation of 4.75. You can check it. Just 10, 15, take it out. Now what left? 0.5 multiplied by 2, so 1.0. Again we will multiply, so take it. So 1, 1, 0.75 binary representation is 1, 1, and for 4 it is 1, 0, 0, right? Now what we need to represent into a IEEE 754 single precision format. So what we need to do, take 1 the left, 0, 0, 1, 1 multiplied by 2 to the power 2, right? We can represent this into this form. Now we need to add bias into a exponent part. So for the single precision, the bias is 127. Now for exponent part, we need to add 127 plus 2. What we will get? 129. Okay. Now 129 is in decimal. So convert it into a binary. It is 129. Convert it into binary. What you will get if you convert it? Already we have converted it into a previous slide. So I am directly writing here 6 times 0, 1. It is binary conversion of 129. Okay. And this is a positive number. So sign or first digit will be the 0. So it is a exponent part, right? And we also got the significant part. So now we need to write it into a IEEE 754 single precision floating point representation. So it is a positive number, the sign bit is 0. Okay. Now exponent, we got this 1, 6 times 0, then 1. This is the exponent part. Now next what is left? That is 1, sorry, 0, 0, 0, 0, 1, 1, and after that 0, 0, 0 till 23 bit, because in the significant part there are 23 digits, so we have to represent into a thing. So first is for sign. Now next 8 bit will be for exponent, and next 23 digit for significant. So how much? 0. Okay. So till 23 digit. The whole it is a IEEE single precision format. Now you can take a double precision format then if it is, or if there is one rule, if it is greater than 255, or there will be infinite representation. There are one question based on that. Just wait, we will moving to the next that question. Then if it is more than 8 bit, then how you can represent on that number. Okay, so now we have got the this part binary representation of IEEE 754 single precision floating point. Now what we need to do, convert it into a hexadecimal, because the answers are given into a hexadecimal representation. Okay, so for hexadecimal what we need to do, make a group of 4 bits in order to represent into a hexadecimal. Already we know that to represent the hexadecimal we need to group 4 bits. Okay, so just make a 4 like this. Now for 3, 1 is here, 0, and again for this. So what is a 0 1 0 0 representation? If you take it 8 4 2 1 directly, so 4, right? Now it is a 0, and for that what is the representation? 1 0 0 1, it is 9, and 1 triple 0 for 8, and now next is 0 0 0 0. It is a hexadecimal representation of this addition. So which one is the correct answer? 4098, 4 times 0. So option A is the correct answer for this question. Okay, so have you got this question? Okay, I hope all of you have got this question. Okay, so moving to the next question. Okay, so next question is x plus yz is equal to x plus y. X plus z is De Morgan's theorem, the associative theorem law, or the commutative law, the distributive law. Which rule it is following? X plus yz is equal to x plus y, y plus z. Okay, yeah, correct. It is a follows the distributive law. Okay, already we know that what is a De Morgan's theorem. So De Morgan's theorem is x plus y bar is equal to x bar into y bar, and similarly x into y bar is x bar plus y bar. For associative law, a plus b in brackets into c, sorry, plus c must be equal to a plus b plus c. Similarly, the multiplication it is also applicable. For commutative, a plus b must be equal to b plus a, or ab is equal to ba. And for distributive law there are 3, also x plus yz must be equal to x plus y or x plus z. So just check whether it is coming equal to this or not. So x into x plus x into z plus y into x plus y into z. It will be the x only, x plus z plus x into y plus y into z. If you take x common, so 1 plus z will be 1, plus xy plus yz. So x again it will be the 1 only. So if you take x common here in both, so 1 plus y will left plus yz. It will again 1. So x plus yz. So it is equal to this one. So this is the distributive law. Correct answer is distributive law. D. Okay. Okay. So moving to the next question. So the next question is P plus P bar plus Q in Boolean algebra is what is this? Is a fallacy or tautology or cannot be determined, or option D is neither tautology nor fallacy. Which option is correct? So how you can prove this one? How you will prove? Yeah, this is a tautology, example of tautology, but how you will prove that? Okay. So first we see the how many literals are there? There are two literals, right? P and Q. So what are the possible combination? 0, 0, 0, 1, 1, 0 and 1, 1, right? So now PQ, we need to find out P bar also because we have to add this. Yeah, so P bar is 1, here it is 0, so 1, 0, 0, opposite of this P. Now add P plus P bar. So 0, 1, 1, 0, 1, 1, again 1, 0, 1, again 1, 0, 1. Now we have to add Q also. So P plus P bar plus Q. Now we need to add P plus P bar and Q. So 0, 1, 1, 1, 1, 1, 1, 0, 1 and 1, 1, 1. So we can see that in the output all are ones. So already we have told that the output, if all the outputs are ones, then it is always true, or it is also called a tautology. If all the outputs will be 0, then it is called fallacy. So it is proved that P plus P bar plus Q is a tautology. Okay. Okay. So I hope 1 plus 1. No. It for or, if you oring 1 plus 1, just check or gate truth table. If you add 1 plus 1, it will be 1. Okay. With no, here we are not following the with carry 1. Okay. Okay. So moving to the next question. Next question is x and y represent two Boolean expression where x is in SOP form, that means sum of product form, where y is in POS form, that is product of sum form. For which of the following cases the Boolean expression as x is y is equal to y? So just we need to check the both form, in which cases the x is equal to y. Okay, so just go option by option first, then we will conclude that whether x is equal to y or not. Okay, so here x is given for option A, x is given ab plus a bar b bar, right? Now solve any one. So I am going to the y, a plus b bar into a bar plus b bar. because it is easy to multiply. So check whether y is coming equal to x or not by converting in sum of product form. So as we know that if you multiply a into a bar, a plus b bar, if you multiply both this, and here a bar plus b bar plus b bar 2 times. So this will be equal to 0, right? It will be 0. So where what we got, a plus b bar plus a bar b bar plus b bar. If 2 times written, so we can write it at once. So now what we can do from here, we can take from anywhere, whether you can make this group or this group. So what left, a plus a bar plus b bar, it is equal to 1. So b bar plus b bar left, we will get only b bar. So x is not equal to y. So option A is not, x not equal to y. Then check for option B. So for option B, what is a y? A plus b multiplied by a bar plus b bar, right? A into a bar just solve with me so that you can able to understand and you can practice more. A plus a bar now plus a into b bar plus b into a bar plus b into b bar, right? So it will be the 0 and it is also 0, right? So what is left, a into b bar plus b into a bar. So check whether x is equal to, here x is ab plus a bar b bar. So that means b also x is not equal to y for b. Option B. It is for option A. Now check option C also, because the last option is also there, D, none of the above. So we need to go here by option and check whether x is equal to y. So x is already given, just we need to solve either x or y. So solving y is easy. You can check like this: a plus b bar multiplied by a bar plus b. So a into a bar plus ab plus b bar a bar plus b bar into b. So these a into a bar, b into b bar will be equal to 0. So what we got, ab plus a bar b bar. So see whether it is equal to x or not. So x is a b bar plus a bar b. It is also not equal to x. So for option C is also x is not equal to y. So correct option is D, none of the above. So in the following cases, the Boolean expression x is not equal to y. So option D is the correct answer. None option is equal to x is equal to y. Okay. This is a week 2 question. Okay. So moving to the next question. I hope all of you have got this. Okay. So the next question is theoretical. So just which of the following statement is false? Just write the question carefully. Which of the following statements is false? Okay, option A is a max term is a sum of all literals within a Boolean expression. So option A is a max term is sum of all literals within a Boolean expression. That is correct. Max term is sum of all expression. For example, there are two literals x and y. Okay, so max term is represented by x plus y, right? The sum of all literals. So it is correct. And next option is the max term should evaluate to 0 for each combination of input variables. That is also correct. It is evaluated for each zeros. That means if you have gone to the last slide in the week 2, so their properties are given. Min terms for which we are representing and for max term for which we are going to represent. Just yeah. So as we know that min terms represented for ones. For example, if it is 0, 0 to x bar into y bar, the sum of product form, and maximum is product of sum form. So for maximum, we take for 0, it is not a complement, but for 1, it is complemented form. Okay. So option B is also correct here. We need to check which statement is false. So option A and option B is correct. So next, move to the option C. So for any two input variables, binary variables x and y, if x plus y represents one of the max term, and then x bar plus y bar would be its corresponding min terms. Just check with the table and see whether this is correct or false. So for any two input binary variables x and y, okay. Yeah, someone is asking, ma'am, please explain the second point. Okay. So the second point is, okay. So max term should evaluate to 0 for each combination of input variables. That means it is evaluated for 0. It is correct now. If you see in the table also that the max term is evaluated for zeros. How you are writing min terms? Min terms is just for example, a 0 0 is 0. It is index is given, but if you add, for example, if you are writing for addition, so what is the min term? It will be the 1, 2, so 1, 2, 3. And for my max term, whatever output is 0, it will be the max term, that is 0. So it is max term evaluate for 0 only, not 1. Okay. Okay, so third is option C is for any two input binary variables x and y. Okay, x and y, it is given in a binary. If x plus y represents one of the max term, okay. For example, x plus y is represent one of the max term. Then x bar plus y bar would be its corresponding min terms. So see what is the corresponding min terms? X plus y is the maximum. So the min terms would be must be x bar plus y bar corresponding for this. So it is a false. Option C is false. Okay. So x bar plus y bar is not uh, is corresponding min terms. So option C is false for this. So what we need to check, which of the following statements is false? Option C is false. So now we need to check the option D. For any two input binary variable x and y, if x, y represents one of the min term. Okay, so check what min terms. M3 corresponding min term for x and y. and then x bar plus y bar would be its corresponding max term. So what is the corresponding max term for x bar plus y bar? So it is correct. It is also correct. So option C is the only false statement. So option C is correct because they are asking for which of the following statement is false. The false statement is option C. Okay. So I hope you have got this. So moving to the next question. So next question is, what is the min term equivalent of a bar plus b bar? So what is the equivalent min term for a bar plus b bar? So how you will solve? First, there are two literals, right? A and B. So you can find it by a table, and another way to finding it out. So by converting it standard canonical form. So that means there are two literals. If one is absent, so you can multiply it by b plus b bar. You have seen in the video lectures, I think. A plus a bar. If you get this, then you will find out the a bar plus b bar, b bar a plus b bar a bar. Now, if you write it in a correct way, so what you will get? A bar, b bar plus a bar b plus a b bar, sorry, a bar b bar, b plus a bar. Okay. Now, we have to make it is getting common in that is b bar a bar, then solve it, or it is equal. So we have to write it once only. Okay, we need to write this part because it is double, so we need to write it once only. Okay, so these are the corresponding min terms, right? So now number it out. A bar b bar represented 0 0, right? It is, what is this? 0 1, and it is 1 0. What is the representation? 0, it is 1, it is 2. So corresponding min terms are 0 1 2. Okay, otherwise in the previous you can make this type of table and check the corresponding, what are the corresponding min terms. Okay. For a bar and plus b bar. So a bar plus b bar, x plus y. So what left? These three. So you can check it from here also. Otherwise you can solve it like this by converting it to standard or canonical sum of product form. Okay. Okay, I will explain it. So already sir has told you one of the his video by to convert it in a standard canonical SOP form, a POS form. So what we need to check, there is two literals, okay, and one literal is absent in this, one literal is absent in this. So you can, so if you want to change it, or you want to find it into literals, so just multiplied by the absent literal by this, because it is multiplied by 1, so 1 is represented by this, right? And similarly here also, a plus a bar, if you multiply you will get ab plus, sorry, this one is a bar, right? A bar plus b bar, so a bar plus b bar, here again b bar into a plus b bar or a bar. So these are the two times, so we can write it once, right? So a bar b bar, plus this one a bar b and a b bar. So what is corresponding representation? You can check in this table also. A bar b bar, just take x in place of x and y, a bar b. So it is represented by index 0, right? It is index 0. It is index 0 1, right? 1, and it is, what is the index for a b bar? Just take a b bar, a b bar. Just take a and b. So 0, it is for 2, it is for 1. So what is corresponding minterm? 0, 1 and 2. Okay. And minterms are represented by this summation part. And for max term, we are represented by this symbol. Okay. Okay. So I hope you understand this. So moving to the next question. So the next question is, what is the max term equivalent of a b bar plus a b? So there are a lot of ways to solving this question. Either you can get first the min term and then check whether what are the corresponding max term from this table. In that session where you are getting your live videos or lectures, there are one tab is live recording session. So from there you can get it, or you have been shared, I think, one uh, that chart sheet something. So from where there also there one presentation and video lectures you will get it. Via mail you are also shared. Okay. Okay. So just let's solve this question. A b bar plus a b. Just try to concise this first. Okay. So just multiply a b bar plus a into a b. Okay, so a into a will be a only. If you multiply a b by this one also, that b plus a b. So it will be 0, right? Now you will get a b. So what we will get? We will get corresponding min terms. It is a min term, right? Because it is a sum of product form, not a product of sum form. So what index it is represented by? 3. So it is corresponding min term. So for now, for max term, we need to choose the opposite of this. So whatever the index are not included in the min term, that will come into a max term. So 0, 1, 2 will be the corresponding max term for this question. Okay. So in order to find it out the max term, first solve this, concise it and find it min term, and then opposite of the min term you will can take the max term part. Okay. So 3, only index 3 into a min term part, so other index are will be the in a max term. So option B is the correct answer for this question. Okay. Okay, so I hope all of you understand this. So moving to the next question. So the next question is, which of the following expression is dual of? So expression is given a plus b in one bracket and another bracket c plus d is equal to ac plus ad plus bc plus bd. What is the corresponding dual terms? So as already we know that what is the principle of duality? So apply principle of duality. duality in which we said that interchange the AND gate to OR gate and ones to zeros, zeros to ones. So what we need to do here, OR is there, just interchange AND to or to AND. Okay. So A plus B, what we can write it, A plus B, A into B. In place of OR we need to apply and here it is AND. So what we need to do, plus, right, and to or to and. Here it is or, so we need to apply or and. Okay, C D, right, this is it, this part, and similarly for this part we need to also change, equal to, here A into C is in SOP form, or here is a and, so A plus C, right, here it is plus, so just change it to and, so A plus D, right, again it is or, so change it to and, here B plus C, and it is also and, or here B plus D. Okay, just check which option is matching with this A plus AB plus CD. Option A is the correct answer. Yeah, option A is the correct answer. Option A is matching with this. Option A is the correct answer for this question. Okay, so moving to the next question. Again, it is based on the principle of duality, dual of the Boolean expression. What will be the answer for this? Just let me know, tell me. It is given A B plus C is equal to AB into EC. AB plus EC. Which answer will be correct? Yeah, option 3. How you will change? Just interchange and to or to and. So here A, here it is and, so it will be the or. Here it is or, so it will be the and. A plus BC is equal to, here A plus B, because it is and here it is or, so and A plus C. Yeah. So correct answer, just check, match it. A plus BC is equal to A plus B, A plus C. Option 3 is the correct answer for this question. Okay. Okay. So moving to the next question. Now next question is related to again single precision IEEE 754 format. So question is, consider the following floating point representation of a binary number in a single precision IEEE 754 format with 1 sign bit, 8-bit exponent and 23-bit significand. So what would be the equivalent decimal number? So what would be the decimal number? So already we know that here if it is 0 it is positive number, if it is 1 it is a negative number. So first check sign bit, it is a negative number. Now the 8-bit exponent, convert it into a decimal in order to find out the, because we need to find out the decimal number. So how you will 2 to the power 0 to 2 to the power 1, 2 to the power, how you will convert 2 to multiply it with the 2 to the power 2, 2 to the power 1, 2, 3, 4, 5, 6, right? No, it will be the 7. 3, 4, 5, 6, 7. 2 to the power 7. Just check it, 2 to the 1 into 2 to the power 7 plus all are 0. So does not require to eat 2 to the power into 0. So 2 to the power 7 will be 128 plus 1, it will be 129. Decimal representation of exponent part. Yeah. So already we know that the bias part is also added in the exponent. So just remove the bias part. Okay. So bias for single precision IEEE format is 127. So just subtract it, you will get 2, right? So exponent we will get exponent is 2 to the power 2. Right? Now convert this part into a decimal. Right? So how you will convert it? Already we know that in a single precision format is represented by 0.0100 till 23 bit. So and it is a negative number, it is not required. So 1.010 multiplied by 2 to the power 2. So what you will get? 0101. It is 1.010. So if you multiply the 2. So what is the decimal representation of it is 5, right? If you multiply it. So and it is a minus 5 because sign bit is 1. So minus 5 will be the decimal representation of the this number. So option A is the correct. Okay. So have you got this question? I hope all of you understand this question. So moving to the next question. Yeah. So the next question is, what are the values of exponent and significant respectively to represent infinity in IEEE single precision floating point number system? So what are the values of exponent and significant respectively to represent infinity in IEEE single precision floating point number system? So in the properties part, we have seen that using IEEE 754 single precision floating point standard and 255, because it is 8 bit, sorry, it is 255, indicates a special value and significant is 0, so it will be the plus minus infinite. If the significant is 0 and so it will represent the infinite. So significant is 0 and exponent is 255. That will represent the infinite in IEEE single precision format. And if its significant is non-zero, so the value will be not a number. Okay, it is given. So option C is the correct answer for this question. Okay, so it is given in the theoretical part. So an exponent of 255 indicates a special value. If the significant is 0, the value will be plus minus infinite. So here in the question they have asked infinite, what will be the represent of the significant. Okay, in IEEE single precision floating point number system. Okay, so significant if it is 0, so it is represented infinite, plus minus infinite. Okay. Okay. So moving to the next question. If a and b are Boolean variables, then a plus b and a plus b are equal to. So how you will solve this? A plus b. So just we need to minimize it. So please, yeah, someone is answering. Okay, yeah, yeah. So just solve it. A into a, if you multiply it, plus a into b bar plus b into a plus b into b bar. So it will be 0, right? and it is a into a is a only. If you will take a common, so it will be the b plus b bar, and it is 1. So what left? A plus a is equal to a only. So correct option is 1. Answer is a. If a and b are Boolean variables, then a plus a plus b multiply a plus b bar is equal to a only. Okay. Yeah. Okay. So moving to the next question. The next question is the minimized expression for. What is the minimized expression for this? Just solve it. What will be the answer for this? So just multiply this one and also expand this part. So a into a is a. I am directly multiplying here, plus a into b bar plus ab plus b into b bar. Now this part also expand this. So it is a whole bar. So if you remove this, so what you will get? A bar, b bar to b whole here. If you do this, so into this plus, so it will be the into and double bar, right? It is equal to 0. So now it is a, and if you summarize it, so you will get a b bar plus b. It is a. Okay, and here if you further expand it also, so you will get here a double bar plus here, because you are expanding it and multiply with a only, because it will cross cancel double bar. So you will get here it is equal to 1. A plus a will be the a only, plus here what you will get? A into a, it will also cancel out, plus a b. So a plus a plus ab, right? A only, a plus ab. Now if you take a common, so what will left? 1 plus b. 1 plus b equal to 1. So what is left? A only. So correct option is, answer is a. Option 2 is the correct answer for this question. Yeah, answer is a. Option 2 is the correct answer for this question. Okay, so I hope all of you have got this question. So moving to the next one. So find the component of the function f1. F1 is given. F1 is equal to x plus y bar z bar plus y z. Find the component of functions f1. How we will find it out? Sorry, complement. Find the complement of the function. So how you will find out the complement of f1? So f1 complement is represented by f1 bar, right? So take a complement of whole function. So x, y bar, z bar plus yz whole complement, right? The 3 option is correct. Okay, solve it. Okay, now minimize this one. Equal to x bar, here it is multiplication, so it will be the plus only. So y bar, z bar plus yz whole bar. Okay, now x is equal to, just solve it more. So y bar, z bar into, because here it is plus, the multiplication y z bar again. So x bar plus, it will again change it, y double bar plus z double bar. It is in multiplication, right? So y bar plus z bar, it will convert. Again we will change it, x bar plus y plus z, right, multiplied by y bar z bar. You can solve it further, but just check with the answer. We need to solve it more, or we can just finish it here also. Okay, if answer is matching here, then you can stop it. Otherwise you can further solve it also by multiplying these two parameters. So we can solve it further also. Y bar, y into y bar plus yz bar plus zy bar into z bar plus. So it will 0, it will also 0. So what we will get, x bar plus yz bar plus z y bar. So first we will see, I think the answer will stop here only, no need to do other calculation. So option 3 is the correct answer for this. The complement of f1 is represented by f1 bar, and that answer is x bar plus y plus z in brackets, y bar plus z bar in the other bracket. So this is the answer. We need to stop here, no need to do further calculations. So option 3 is the correct answer for this question. Okay. Okay, so I hope all of you understand this. So moving to the next question. Yeah. So next question is, if function f(x,y,z) is equal to, that means min terms are given. The min terms are 2, 3, 4, 5, is implemented using sum of product form, the resultant Boolean function would be. What will be the resultant Boolean function? So it is given f is, the function is given f of x, y, z. Min terms is given 2, 3, 4, 5. What is a binary or representation of corresponding index? It is represented by 0, 1, 0, right? It is 0, 1, 1. 4 is represented by 1, 1, 1, 0, 0, and 5 is represented by 1, 0, 1, right? If you make a table that is 0 x for corresponding x, y, z, 0, 0, 1, 0, 1, 0, 0, 1, 1, for taking all possible values, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So corresponding, what is the corresponding index? It is 0, it is 1, it is 2, it is 3, it is 4, it is 5, 6, 7, right? It is 2. So it is given 2, 3, 4, 5, 2, 3, 4, 5. Thus, this is the corresponding index. Now we need to write corresponding the Boolean function. So what is it? 0, 1, 0. How you can represent it? 0 is represented by x bar, right? Sorry, x bar, it is in capital. Then y in sum of product form we have to write. Z bar plus sum of the product plus sum. So it is x bar y z. 2 is represented by this. And for 4 it is x y bar z bar. For 5 x y bar z bar, right? From just wherever 0 is there, you have to write in a complement form. Wherever it is 1, write a ones form, not complemented form, for sum of product or in terms of min term. Okay. Now further, if you solve it or minimize it, you will get the resultant Boolean function, right? So now just take x bar y common in these two. So you will get z bar plus z, right? If you take in both. And what is the common factor here? X, z bar. Here it is also y plus y bar left. So it is 1, it is 1. So what you will get? X bar y plus x z bar, right? X bar y plus something is missing. X bar y, x y bar it should be. So just take a common like x y bar. Sorry, from here we need to take x y bar in these two. It is z z bar. So x y bar will be x bar y. So if you further see that in again other lectures, you will find it out. X bar y plus x y bar is represented by this symbol. This is called XOR gate symbol. Okay, it is not strict, but you can just check. The otherwise answer is x bar y plus x y bar. Okay, so this function is represented by XOR gate. You will study in further next week lectures. So by mistakenly it is came in this. So just option 3 is correct. Okay, I will explain it again otherwise. Okay. Okay, so moving to the next question and the last question. So next question, solve the following Boolean algebra expression. That is, we need to solve it. Again, just minimize it. A bar B plus C. A bar B C plus C bar. It is C. Just first multiply this A. Just try to minimize it. So A into A bar plus A into C. Right? You will get in one bracket. Again A bar B. Yeah, you will get 0 in final. Plus C. Next one is A bar B C C bar. So it is 0, right? A into A bar. Now only AC left. So just multiply AC in this. A C A bar B. I am multiplying AC in with this plus A C into C. Again it is in bracket. A bar BC plus C bar. So again A into A bar is there. So this equation will get to 0. It is also 0. Right? So what left here? It is 0. So again A into C into C. AC only. AC. A bar B C plus C bar. Now again multiply this. A C A bar B C plus A C into C bar. Again we know that C into C bar will be 0. Again here it is A into A bar is there. It is also 0. So 0 only because all the terms are cancelled out. Okay. Okay. So option 3 is the correct answer. Answer is 0. Option 3 is the correct answer. I hope all of you have understand these questions. So now the questions problem set has completed. So thank you everyone. If you have any doubt, you can ask. Otherwise, we can close the session. Yeah, if you have any doubt, otherwise, we can close the session. Okay, today there is no doubt. Okay, so yeah, thank you everyone. Thank you for joining. So now we can close the session. Yeah, thank you everyone.